Hey Maddie, here's my here's my thoughts on this question. So Kramer's rule, I hope you're kind of familiar with that. It's basically kind of another way to solve matrices. So we could just take this matrix right now and just plug it in and solve it or do row operations, that's fine. Kramer's rule figured out that if we calculate the determinant, remember, and the determinant is just a number, it's the difference of the two cross products, right? So 5 times -3 minus 6 times 7. We just figure out that number, that's the determinant. If we find the determinant of this matrix right here, not with the solutions, then we take the solutions, replace the first column with the solutions, figure out the determinant of that. Then we take the solutions, replace the second column with the solutions, figure out the determinant of that. We could figure out what x and y are at the end of the day. It's kind of a pretty neat idea, but it's just like another way to solve matrices. Okay, so if we're going to do that, first let's find d. That is just the determinant. Okay, so that's only the determinant of this little matrix right here. We're going to go 5 times -3, that's -15, minus 6 times 7, that's going to be 42. Okay, so we just calculate that number now. -15 minus 42, what's that? -57, I'm going to say. So there we go. So that's D. Make a note of that somewhere. D equals -57. Okay, so that's that. I'm just going to erase this now to make some room. Then what we do is we're going to find D of dx. We're going to take the solution set, we're going to replace this column, because remember this is all the x variables, right? Our first column is all x's, and then we'll do the same thing. So that would be -13, 30, and we just keep the second column the same, 7 and -3. So that's like our little minor matrix here that we're going to figure out. Now again, we do the determinant. So that's the cross products, right? -13 times 3, that's going to be 39, positive 39, minus 30 times 7, that's going to be 210. I have no idea what that's going to be. We can figure it out. We'll get the calculator out. Might as well do that up now, eh? 210 minus 39. I'm doing it out by hand, but you get the idea. Do it out by hand. Be proud. That's what I say. 171. So minus 171 is dx. Okay, so make a note of that. dx equals -171. I'll erase my mess again, and then we'll do dy. And we can do this for as many variables as we need to. If we had z's or w's in this, we could do the same deal. So now let's calculate the determinant of y. Now I take my first column, that's going to be the same, 5 and 6. Now I replace the y column with the solutions, -13 and 30. And again, we just calculate that determinant. 5 times 30 is going to be what? 60? Minus 6 times 13. No idea. 8, carry the 1. That's going to be minus 78. Right? So dy is going to equal -18. Okay? So dy equals -18. Great. So now that we found the determinant of x, or dx, and the determinant of y, we can actually kind of start solving this thing to figure out what x and y are. And you can probably tell from the solution set here, we're going to be going into fraction land, of course, right? So x, oh, come on, pen. Come on, baby. There we go. So x equals dx over d. So if we divide dx with d, that gives us x. And you can kind of see the algebra in that, right? The d's would cancel. D divided by d is 1. And y is the same thing. It's going to be dy divided by d. So that's why it's good to write them down. So dx is -171 over d, which is -57. So that's basically positive, right? 171 over 57. Because remember, two negatives make a positive. Might want to double check that and make sure we're in lowest terms here. Y, same deal. dy is going to be -18, and we'll divide that by d, which is again -57, which equals 18 over 57. And again, it might be a good idea to make sure you're in lowest terms here, but that's kind of the idea, buddy. So blast her in right there. Okay? So Kramer's rule, pretty neat. It's just a different way to solve matrices, and it actually works, and it works every time. So that's kind of the fun geekery of math, I guess. If you have any questions, let me know. Enjoy your night.